concentrating isopropyl alcohol. Let's get into it.
Alright, so essentially we're taking a 70% mix of isopropanol, which is relatively dilute, and adding some salt. What happens is that the salt dissolves into the water, or the aqueous part of the solution, but not into the isopropanol part. Once the salt dissolves into the water, it forms a significantly more dense aqueous layer than what the isopropanol is. So the more concentrated isopropanol floats to the top, while the more dense salt layer sinks to the bottom. In order to get this going, you have to agitate it a ton with a lot of stirring. That's pretty much it.
Alright, I've had it on the stir plate for a little bit of time now. I'm going to turn off the stirring. It looks like most of it kind of cleared up, so I'm guessing as much salt as could dissolve in did dissolve in. And then there's a lot of excess salt there at the bottom. So I'm going to see if we get any separation of the layers right now that it's not being agitated. Let's see. So I went at it with a stir rod for like about a minute, and there's something happening. There's definitely a thicker layer down here. It's barely discernible though. I'm not sure if I'm getting a full separation yet though, but you can see like right there. It's kind of like bubbly. I don't know. We'll see. I'll check back in if anything happens. Alright, I've let it sitting for a couple minutes, and it's kind of hard to see the distinct layers now. It's still separating. But I went and got a piece of printer paper, and I'm not sure if that helps. But you can see that that layer right there is a lot thicker and kind of cloudy, and it almost looks like some kind of colloidal suspension. And then up here, there's this layer that's perfectly crystal clear. So this is going to be the isopropanol in near its azeotropic form, which should be 91% by either weight or volume. I forgot which one. It's very little water. And then down here is going to be our concentrated brine wash, which is the sodium chloride dissolved in water, and then all of our excess sodium chloride. So I'll leave it for a few more minutes to separate, and then I will filter it off. But it looks like it's doing pretty good. Alright, so that's 35.680 grams per 10 milliliters. Let's go calculate our density and in turn the concentration of our isopropanol.
After comparing my data to a chart I found online, it revealed that the concentration of my isopropanol at room temperature, volume over volume, was 75 to 76%. This was a lot lower than I'd hoped. I decided to try again.
Bro, I'm cleaning up my beakers and there's like copious amounts of salt in the sink. Oh my god.
After somewhat chaotically cleaning up all my beakers, I decided to transfer all of my isopropanol, as well as a new fresh bottle I had yet to open, into a new beaker. I mixed it around with copious amounts of salt and let it sit for about 3 days over the weekend. Once I came back to the lab, I again determined the concentration by density, and this time I was pleasantly surprised with a concentration of 85%. Not bad, but definitely not practical or cost effective.
Safety glasses off, motherfucker.